because it supports an universal code. So universal code, we call it as Unicode. Instead of ASCII code, it supports an Unicode system. Whereas the ASCII code is of length 8-bit only. So it means only a maximum of 256 different types of character will be recognized in the ASCII codes. Whereas the Java is not directly, it supports with only for the ASCII code. It supports an extended version of the code, and that is the Unicode version. So in this Unicode version, what they've done, so they used for that 65 characters for different country languages. Like I just mentioned here is the United States, Western European languages, Russian, Chinese, and so on. So, okay. So each and every character we can recognize it in this character data type. So for that reason, it is the 2-byte length. And the default value, it stores in the form of like 4 zeros. Okay, that means it is also one type of numbering. That's why it will be represented as 4 zeros, in the sense it's a 16-bit, all bits are 0. And whenever you want to store a character type, either you can follow an ASCII code character representation or Unicode character representation. If you need an ASCII code representation, just you can use the single quotes. If you need the Unicode character representation, at that time we are using within the single quotes /u followed by its value you have to represent. So this value, what I am representing 00040, we call it as an hexadecimal value. So you can use here the hexadecimal, that value of that. Which character you want to use, that character will be having that value you can represent here. And the next data type is available here is the byte. So byte is nothing but it's a 1 byte of memory location, and it is of type integer number. So whenever you need only an 8-bit data representation, at that time you can go for the 1 byte representation. So byte 0, and the default value it stores is 0. And the short, the default value is 0, and the memory location it allocates is for 2 bytes. So it will be occupy only 2 bytes of memory location. And integer default value is 0, and it will be occupy the 4 bytes of data. And the long, so long is occupied as a default value is 0L. So we represent here is 0L, that indicates it is a long data type, and it will be occupied 8 bytes of data. 8 bytes of memory will be occupied. And next is a floating point. The floating point will be default value is 0.0f, and it will be 4 bytes in length. And double, the double default value is 0.0d. So the d and f is a differentiation between the floating point representation and the double point representation. Double will occupy 8 bytes of memory. So I think all these data types you already studied in your previous programming language, except some difference is here is with respect to this character. So here the character is a 2 bytes in length. So if you want any other language characters, you can use in your Java program. Do you have any doubt? Do you have any?
No, sir.
Fine. Somebody is asking.
F and D in the default value of float and double.
Pardon? I'm not hearing. Just.
So in the
yes. Float and
double.
This is for a differentiation between the double and float, because the double is called as an 8 byte. Okay, it means it's a 64-bit representation. Okay, it's a 64-bit IEEE representation, whereas the float is a 32-bit floating point representation. Okay, so IEEE floating point representation, you already know that. So it uses 32-bit and it uses 64-bit. So for example, if you represent it as 0.0, so I need to convert this into either float or double. So based on that, we represent here is the F and D. The same thing here, see, when it comes to integer, 0 is also support integer as byte as well as short. But whereas in the long, if you need the long representation, we can just add an L for that. Because it has to convert what type, whether it has to be an integer or whether it has to be long. Like that, if I represent 0.0, whether it should be an float or double. So for that reason, we'll add it this F and D. Is it clear? Yes? Do you have any other doubts? Yes? Yes or no?
sir.
Yeah? Okay. So from this, I'll move on to the next slide. Now, Java is, we discussed the data types as well as the Java supports the operators, and this operator is almost same as what it is available in your other programming language. Okay, but a few of them are different. Okay, so some I listed here. All the data types which supports by Java operating system are represented here. So we have the operator type is unary or arithmetic or relational or bitwise or logical or assignment. Like that, we have a statements operator, different category of operator. Okay, so unary operator. When it comes to unary, so we have two types of unary. One is postfix, another one is the prefix. So when I take plus plus minus minus like that, so it will be having the postfix as well as prefix. So expression followed by plus plus we call it as a postfix, and expression followed by minus minus is called as a postfix. The prefix will be start first operator then expression. So for that reason, the prefix operators are like say plus and minus. These all are called as unitary. Okay, as well as we have a tilde operator and explanatory symbols. So these are the unary operators which are available in Java. We'll go with some one example with this programming. And arithmetic operators, as we know that addition, subtraction, we have addition, subtraction, plus and minus operator. And for multiplication and divisions, so we have three operators. One is star, slash, percentage. The star is called as a multiplication. Then division slash is called as division operation, and the percentage is called as the modulo operators. Okay, and we have the shift operators. So there are three types of shift operators are there. The first one is just double less than, other one is greater than, double greater than symbol, and the third one is greater than symbol, three greater than symbols. So what is this double less than and greater than, double greater than?
Left shift, right shift.
Okay, left shift and right shift. So when you go in other programming language C, C++, so it will be having left shift operator as well as right shift operator. So what does this left shift and right shift operator is? See, it fills the either zero at the right side or left side, we call it as fine. But what happens here, it keeps the magnitude. It keeps the magnitude back. So what is the meaning of that magnitude in the sense? We know that whenever you represent anything, so it will be having a number. So for example, this is a number. So 1 bit, we are using for always the S bit, sign bit. This sign bit we need to perform, like see, whenever I filling back to the same sign bit, that is nothing but we are keeping the magnitude same. So if the sign bit is 0, we need to keep back to the again sign bit 0 itself. If I need to keep that minus, I should have to keep that as a minus in the sense 1. So retaining of this bits is one operator. The other one is simply I can add a 1 0 here based on whether left shift or right shift, and either we can add at the right side here. Okay, so if your data is left shifting, what does it will add 1 0 here, it will add 1 0 here, and the remaining push to the next. It will go on like this continuously. Fine. Again, keeping this data back to the here, okay, it's called as magnitude keeping. So whatever the bit will be available here, the last bit will not move to here. So this bit will again retain back to here. So that is what we call as the left shift and right shift operator. Whereas the Java is having an one more extra called as fill zero right shift operator. The fill zero right shift operator. The fill zero right shift operator in the sense what? Even though if the sign bit is 1 here, it won't keep back to the again here. So what does? It simply fills that 0 here. Okay, even if it is a 0, there is no difference. If it is already 0, keeping that 0 is nothing but same. But if the bit is already 1 here, sign bit is 1, so it will remove that sign bit, that bit will move to the next here. So 1 will be moved to here and 0 will be comes to here. That's what we call as the 0 filling shift operator, right shift operator. Is it clear?
Yes, sir.
So this is the one difference with respect to your previous programming language, what you studied C, C++. With respect to that, this is the difference we have. Okay, and next we come to the relational operator. So there are relational operators, we already know that less than, greater than, less than or equal to, greater than or equal to, then double equal, not equal. So these all are the relational operator which is available in previous language. Here also same relational operators are available. And when it comes to the bitwise operator, okay, so there are bitwise and logical operators are available in Java. So one called as bitwise and, so it is called as just an and symbol, bitwise exclusive or the cap symbol we are using, and bitwise or operator is a vertical line, just vertical line, we have to use it one. So this becomes the or operator, and exclusive or operator. Fine. So it is available in Java also, as well as in your C also. I use this one already know. And logical operators, when it comes to the logical operators, there are two types of logical operators. We call it as one is logical and the logical OR. So this we call it as logical OR and operator, and this is logical OR operator. So in your C, have you used all these types? Have you used all this type?
Bitwise we don't
Have you used it?
So bitwise we haven't used it.
Then how you will perform the bitwise operation in C?
So we haven't performed it.
You haven't performed. You have not written any statement like this. Say for example, I'll write A is a one integer data type. I want to perform A, okay, and B. So what happens when I write like this? Or when I write A equal to, okay, A and B. Okay. So now see, when I write like first only one operator with this, we call this as the bitwise AND operation. So bitwise AND operation in the sense, what it does, whatever the value it is available in A, it will take the value of A. For example, assume that a value of A is having in the form of binary like this, 0, 0, 1, 1. Fine. And the value of B is having like value 0, okay, 1, 1, 0. Fine. when we have the value of A is this, okay, and the value of B is this. Now, if I'm performing the first expression, A equal to A only one operator and B, then what does it does? It performs the bitwise logical operation. That means it performs the 0th bit of A with the 0th bit of B and operation. Now what happens here? 1 and 0 and operation is what?
0, sir.
Is you will get the result is 0 because we know that RD. So 1 indicates true and 0 indicates a false. So true and false with respect to AND operator is false. Now 1 and 1 is nothing but 1 and 0 and 1 again 0 and 0 0 is 0. So it means the value of A becomes this. When you perform the first expression A equal to A and B, so if value of A is this, value of B is this, it performs this operation. Fine. Now, whereas in the second operation, if I write A equal to A double and B, in the sense it will be treated, this A should be either a 0 or 1. The B should be treated as it's a logical either 0 or 1, not in the form of number. Okay, not in the form of number. So then when we have to use this double operand, because of if the value of A is either 0 or 1, the value of B is either a 0 or 1, at that time it performs only one logical operations like 0 and just I'll write 0 and some 1. If A is 0 and B is 1, it performs 0 and 1. If the A is 1 and B is 1, it performs 1 and 1. So for that reason, whenever we need this type of result, bitwise operation result, we need to go for the single ampersand and the exclusive or operator. If you want to perform this type of operation, then we need to go for the logical operators. These logical operators are especially we are using with a combination of this relational operator. Say for example, I will write a condition like if A is greater than B, if A is greater than B, then and B is some greater than something C. Okay, I need to perform, if both are true, I need to perform some operation. At that time, we can use this ampersand symbol. So we can add this for the any if statement or something. Okay, so because here, when it comes to here A and A greater than B, it will return either true or false. If the A is larger than B, it returns a true. Okay. If B is greater than A, that means the value of B is greater than A, then it returns true. Sorry, I'll write something other than this. Yeah, B is greater than C because both are in the same format now. Now, if this is true, then what it performs, true and true, you will get the result is true. Fine? Is it clear? Fine.
Yes, sir.
So, whenever we need any logical result with the individual bit operation, we go to the bitwise operator. Whenever we need only the comparison results has to be either both are true or false. At that time, we can go for the logical operators. And one more, we call it as here logical. This logical AND operator and logical operator, sometimes we call it as the short logical operator. It's called as the short logical operator, okay, and logical short operator. So what is the meaning of this short in a sense? It is called as a shortcut. So if I'm perform like say, if I need to perform this AND operation here, Now see, if I'm performing this double ampersand symbol, at that time, if this first condition is false, then it is not necessary to do this operation. Can we require that operation? If the first result A greater than B is itself is a false, then it is not necessary to check the rest of the operations. So rest of the operation in the sense B is greater than C and check it, then we'll get true or false. Then you perform the true is not required. Okay. So for that reason, what does the Java is here? Whenever we write this logical operator and or we call it a short. So it means if the first expression itself is a false, automatically it won't perform this. Okay, it's shortcut. That means it will be terminate there itself. So for that reason, it won't perform any other rest of the operations even if this condition is false. Same thing when it comes to OR operation, if the first condition is true, then it won't perform the next part. By chance, if this first condition is false, if you are using a logical OR operator, then it go for the next. Expression to perform. Okay, so sometimes called as the shorthand, okay, logical operator. Okay, sometimes short circuit logical operator. The short circuit in the sense, if this is itself is true, it becomes cut signal. So it won't perform this operation. So that's why we call it as it's a shortcut, okay, logical operators. Is it clear?
Sir?
Yes.
Sir, if we use logical operators other than true or false, will it give an error or any output, sir?
Pardon?
If we use logical operators for other than true or false cases, will it give an error or will it give an output, sir?
What does it will? It will take that as an non-zero and zero. Got it? But usually it has to be given error, but what it does, it will check the non-zero and zero values. So if it is a non-zero value, what we call as usually true. It is a high logic.
Yes, sir.
Okay. So automatically what happens? It will go to true. If it is a zero value, it will come to the false. So for that reason, you are the programmer, you know that where I want to use a logical operator, where I should have to use the bitwise operator. Okay. So while using any logical operator, double and symbol or double vertical line symbols, we should have to use, okay, some relational operators. The relational operator I have to use, or we can use the two variables A and B. Say for example, I want to write here A double and B, this expression. Fine. So at that time, your variable, that means A, B should be of type Boolean. If you write A and B is of type Boolean variables, then it will be Boolean variables. We already know that it will be having either true or false. So at that time, we can directly write this. By chance, if the value of A and value of B is non-Boolean, it means it is of type integer or it may be floating point or any other. So at that time, so what we have to consider, whether we have to consider as a true or false. For at that time, what we need, we can use some relational operator for that. Then that relational result, you can use it for the AND operations. Okay, fine. Then we move on to the next operator, that is what we call as a ternary operator. So ternary operator is same as in C++. Okay, question mark and followed by colon. So question mark and followed by colon in the sense, first we need to put the true, okay, condition, then question mark, then we need to be true statement, then colon, the false statement. Okay, so if that particular first condition is true, it has to execute the true part. Then after the colon, else part. Okay, it is same as if statement. Instead of directly using if statement, we are using this ternary operator. And assignment operator, we know that assignment operator is first one is equal, then followed by we can add any arithmetic operators or logical operators with that. Okay, we can do both assignment statements, say plus equal, minus equal, star equal, like that. We can perform all these operators, whatever we are having, that we can add it. Okay, and what I'm showing in this table, okay, the table will be having like the precedence. Okay, so when it comes to here, it's a lower precedence. Okay, this part is lower precedence, and when you move on to here, it is an higher precedence. So precedence of operator will be in such a way that it will be having like this. So unary will be having first, highest, then go on, continue. It will come to down to assignment statement. So assignment statement is the lowest precedence. Okay, any other doubts do you have in this slide? It's fine. Now I just taken one example here, see. So I taken one example, the class, and followed by a class name is operator example. Fine. So in the main function, I'm not adding any data member till now, because once if I clear the classes, then I'll add the objects data member. Now I'm using only the main function. So public static void main string args. Fine. The next I can add it here. See, there are two variables I've defined. One is int a and b. Fine. Then one other variable called as boolean, the flag, and the value is false. By default, value is itself is false, but once again I will assign that to the false. Okay. And next, when it comes to here system.out.println, so I'm using here printing with an arithmetic expression. Now see, a plus plus plus, okay, plus plus a. So as RD we know that, so unary operator will be having highest priority. So what it does, it first performs these two operations. Okay, then the plus operation it performs. So for that reason, what I'm saying here is, see, it is the post increment, whereas this is the pre-increment. So for that reason, first it will take the value of a. So value of a is 10 here it takes. Then it will be incremented here. Then that value will be comes to here, and that is the pre-increment. So pre-increment in the sense 10 becomes now 11. 11 again it becomes the 12. So you will get the 12 and plus operation. The result you will get it as 22. Okay. Same thing I given here is, see, b plus plus and plus b plus plus. So the value of d, it is also post increment. Post increment in the sense, first take the value. The value of b is 10 we are taken. Fine. Then it performs the increment operation. Then it comes to here. So when it comes to here, this part is again what? It will be post increment. That means only take the value of b. So value of b will be takes as 11. Then that value is increased. B will be increased by 11 to 12. So when you print after this statement, print statement with a b, you will get the value is 12. So now it adds 10 plus 11 equal to the 21. The result it will be prints as 21. Now same thing here, see, system.out.println. So if I use a explanatory symbol, so we call it as explanatory symbol is a not operation. So not flag in the sense, so flag value is false is there. So it will convert that into opposite. It means its opposite is the true. So the output it will be displayed on the screen is true. Okay. Then I added one more statement here, system.out.println followed by and tilde operator with A, fine. Then I'll not mention anything here. Okay, so I'll not mention anything, just question mark I'm putting. You can find out its value, what you will print, what it will print. Do you have any doubt in this program? Any doubt in this program?
No, sir.
The last printf statement is there, no printf statement. Find out yourself what is the value it prints. Then you can identify what it does, your tilde operator. Okay. So in my previous slide also I have not explained that. Just I mentioned that it's an unary operator. Just I put. Fine. So what does the tilde operator? You can identify it.
Tilde
Okay.
operator does the complement.
Huh?
So it does the complement of the number.
Check it, result. You take the value I given here. You take this same program, execute, you will get this output here. You compare that output with the A, what it does. So do it yourself. This is the task for yourself. Okay. Any other doubts? I'll ask this output in the tomorrow. So those who will get, those who are analyzed, you can explain. Now move on to the conditional and looping statements. So see how the C programming and C++ programming supports looping and conditional operator. Java is also supports conditional and looping statements. So as usual, the first conditional statement which is available in every programming language is if-else statements. So Java is also having the if-else statements. I'll not go through more because this is the common statement which is available in all programming. So if followed by condition, then true statement, then else false statements. That means if the condition is true, what it has to execute. If the condition is false, what it has to execute. So that part of the code we should have to write here. Now I'm just given one example here in the main program, main function. So I just declared number is 13. Then I added some statement like, say, if number modulo 2 equal to 0, then print even number, otherwise odd number. So if the number is 13, so 13 modulo 2, it gives 1. So in the sense condition fails, in the condition phase, it will print an odd number. It will print the result as odd number. If I change this value 13 into its equivalent, like say 10, so then it performs the 10 modulo 2. So that remainder is 0. So the remainder is 0 in the sense it's an even number. So it will print the result as even number. Okay, just simple one example I given here. I'm not explaining all this part. So this is about the if statement. Next, Java is supports one more statement, that is the if-else ladder type switch statement. Okay, that's we call as the if-else ladder. So if-else ladder, we are converting it into switch statement. So it will be having a same thing here, the keyword switch followed by an expression. Then within the flower brackets, we can represent the case. So case followed by value 1. And if this value is matched with the expression, then execute this part of the code, then break the statement. So then the optional I mentioned that is, you know that when you not put this, what happens? When you put this, what happens, you know. So case 1 value, true, fine. Case 2, its value, execute this part of the code, then break that. So like that, we can add it many number of cases. And then the default statement. So if any of these cases is not matches, then it goes to the default value that is lost. We call it as else statement. So in this default else statement, it will execute this part of the code. And here we are not putting any break statement because after this we do not have anything. So directly it will come out from the switch case. Now I just given here one switch statement with example. Okay, I'm taken same previous example, number equal to something, then switch number. So if this number value is 10, I'm printing in the word 10. If it is a value is 20, I'm printing as 20. Okay, if the value is 30, I'm printing that in the word as 30 and I'm applying the break case. So if the value of this number is other than these first three cases, so it means it is not the 10, it is not the 20, or it is not the 30, then the default value it comes default. I'm putting system.out.println not in 10, 20 or 30. So your number is not in 10, 20 and 30. Is it clear? Any doubt?
No, sir.
Fine. I think now this is a time up. So I'll stop it here. Before that, I'll take the attendance.